Have you ever walked across a carpeted room and felt a zap when you touched the doorknob? That's static electricity at work, a force that exists everywhere around us. It's a fundamental aspect of the universe, hidden in plain sight. We often encounter it in our daily lives, though we may not always recognize it. Static electricity is all about charges. Everything in the universe is made up of tiny particles called atoms. These atoms contain even smaller particles called electrons, which carry a negative charge. Think of it like this. Some objects hold on to their electrons tightly, while others are more willing to let them go. When two different materials rub together, like your shoes on a carpet, electrons can jump from one to the other. This creates an imbalance of charges. The object that gains electrons becomes negatively charged, while the object that loses electrons becomes positively charged. These opposite charges attract each other just like opposite poles of a magnet. This attraction is what causes that shocking experience when you least expect it. Imagine rubbing a balloon against your hair. The balloon, made of rubber, is good at attracting electrons. Your hair, on the other hand, readily gives up electrons. As you rub, electrons from your hair leap onto the surface of the balloon. This leaves the balloon with a surplus of negative charges. Your hair, now missing some electrons, becomes positively charged. That's why your hair stands on end after a good balloon rub. Those positively charged strands are trying to get away from each other. This transfer of electrons from one object to another is what we call charge separation. It's the fundamental principle behind all static electricity phenomena. Even the simple act of walking can generate static electricity. As your shoes rub against the ground, electrons are exchanged. This is especially true on dry days, when the air itself doesn't have as many free electrons to balance things out. Static electricity doesn't stay static forever. When the buildup of electrical charge becomes too great, it finds a way to neutralize itself. That sudden release of stored energy, often accompanied by a spark or a shock, is what we call static discharge. Remember that doorknob shock? That's your body, having picked up extra electrons from walking across the carpet, discharging that excess charge to the metal doorknob. The spark you see and the shock you feel are both manifestations of that rapid flow of electrons. Ever notice that you experience fewer static shocks on humid days? That's because water molecules in the air are good at absorbing excess charges. They act like tiny peacekeepers, preventing the buildup of static electricity by providing a path for electrons to flow more freely. In essence, static electricity thrives in dry conditions and struggles to make an appearance when it's humid. Section 4. Lightning static electricity's grand spectacle. Now, imagine static discharge on a much grander scale. That's lightning. Lightning is nature's most dramatic display of static electricity. Inside a thundercloud, tiny ice crystals collide with larger hailstones, creating charge separation. The lighter ice crystals carrying a positive charge are swept upwards by powerful updrafts. Meanwhile, the heavier hailstones, carrying a negative charge, gather in the lower portion of the cloud. This separation of charges creates a massive electrical potential difference between the cloud and the ground. When this difference becomes too great, a surge of electrons races down from the cloud, meeting a corresponding surge rising from the ground, creating a brilliant flash of light and a deafening clap of thunder. Lightning is a stark reminder that static electricity is not just a minor annoyance. It's a powerful force of nature, capable of awe-inspiring beauty and terrifying destruction. Section 5. Respecting the power of the sky. Lightning is a serious hazard. If you find yourself caught in a thunderstorm, seek shelter immediately. Stay away from open fields, tall trees, water, and metal objects, as these can provide a pathway for lightning to strike. Inside your home, stay away from windows, plumbing, and electrical appliances, as lightning can travel through these conduits. Remember, when thunder roars, go indoors. It's the safest place to be during a thunderstorm. Scientists are constantly learning more about lightning. They use sophisticated instruments to study its behavior and predict its path. This research helps us develop better lightning detection systems and safer building practices. The study of static electricity, from those tiny sparks to the awesome power of lightning, continues to fascinate and challenge us. As we delve deeper into the mysteries of this fundamental force, we gain a greater appreciation for the intricate workings of the universe.